Hi, I'm Mohammed Al and today I'll be doing a display on Kinetics. Right now I'm cooking some eggs, trying to make some boiled eggs. I, will- I apologize for the pot. I mean the lid. It's just that it's been fogged up so much that I hardly had any time to clean it. So I gotta make, I gotta do a display on it. Now, ignore the eggs. Just watch the water. It'll tell you anything about kinetics. Oh, fun thing about kinetics. Kinetics is the study of thermodynamics, which revolve around the usage of potential energy and kinetic energy in the various forms of living organisms. But keep in mind that there is one rule you must obey. Energy cannot be destroyed or created. It needs to be transferred from one point to another. Or, in this case, it can be transformed. So, yeah, first I'll start off with kinetic energy. Well, if you look at it, it's just something very small, but sooner or later it will boil. You just have to wait. And trust me, it'll take a lot of waiting. Ugh. On the other hand, if you might not notice, but kinetic energy is practically the energy of movement. Kinetics is very complex in terms of chemistry because in every human body there's always kinetic energy in the works. So, why do you think a lot of athletes go around running around the racetrack? That's an example of kinetic energy. The same the same thing can apply to a rock to a space station moving constantly around orbit around the Earth. Do you want to know why a lot of guys at NASA need a lot of training in order to operate a rocket? Well, for one thing, they need to withstand the kinetic energy generated by the ignition of the rocket. Otherwise, they'll wind up getting slammed right in the face. And trust me, you don't want to have your skull turned to your skeleton turned to a pancake. Oh, and one thing. The thing about kinetics is, it's all about the energy of movement. So, I know I stated that before, but listen. You see me moving, that means I'm displaying kinetic energy. And you see me, and you see a human being running around, watching, watching people run around the park and jogging. That's kinetic energy as well. There's also a display with archery. Have you guys ever played archery before? Well, it's a very fascinating sport. It's all about accuracy and precision. So, as I explained in the science of this experiment, well, I know the eggs are kind of unnecessary, but the eggs were kind of an unmovable object, so they have a lot of potential energy. Potential energy is actually the study of how much power can be stored up in an object. When it releases itself from the object, it becomes a lot faster. I know, and that also applies to archery as well. You see, uh, in the form of archery, it's always about the pull of the arrow. The reason the arrow flies so fast because of the potential energy generated by the pull of the bowstring. The longer you hold the line, the faster it will go. That's why all the potential energy will convert the arrow will make the arrow generate massive amounts of kinetic energy. And most of the time, anyone who generates kinetic energy will exert heat. So, when you start to heat up something, there's a lot of energy is going to be released. Now, hold on, let me clean my lid. And it's gonna take a while for the eggs, for the water to boil. So, I hope you guys don't mind if I do some cleaning. Mm-hmm. 。 . 。 。 。 . 。 . 。 . 。 . 。 . 。 . 。 . 。 . 。 . 。 . 。 . 。 。 。 。 。 . 。 。 。 。 。 。 。 。 。 . 。 。 。 。 。 。 . 。 。 . 。 . 。 . 。 . Yeah, there. Not fogged up anymore. Hold on. I need to clean this. Hold on for a sec. Okay, as soon as I know this might sound difficult, but sometimes since I don't have much to go around to display potential energy, I thought it might start something simple. You might find this a bit insane. Okay, just pay attention. Okay, just grab one sugar cube. See what I'm holding? This is a sugar cube, or in this case, I know, there are a lot of varieties of sugar cubes around here. So, look at the sugar. Now, see if what happens when I place it on the tape, place it on the counter. Hold on, I need something clean. There, see? Now, imagine this sugar cube as a huge boulder in the forest somewhere in California. Or in this case, if you want, try the Colorado Mountains. Or or however you say it. Now, let's check the progress on my kinetic energy experiment. If you notice by the sound, the substance is about to heat up. And if you look at the vapor, it's boiling. Until it reaches its boiling point, you're not going to see any gas bubbles anytime soon. Another thing about kinetic energies is the gas bubbles. You see, in kinetics, most of the time you would find gas bubbles at the center of everything, because gas bubbles move so rapidly that they have massive amounts of kinetic energy. So, if you would melt all the ice into vapor, all this vapor would start flinging around in the atmosphere, like a game of ping pong, or in this case, pinball. Pinball is also a great example of kinetic energy. Each time you increase the speed, each time you pull the plunger of that launcher, the pinball will rise, will become as fast as a lightning. Will be fast as lightning. Yes. Also, you had to watch a guy play pin. If you watched someone play pinball before, you will understand. You had to keep an eye on the ball and keep playing with the bumpers and the flickers. Or in this case, the flippers. The longer the stored up energy, the longer the ball moves, the more kinetic energy it generates. Oh, and I have not mentioned that all this also requires potential energy. For one thing, in the game of pinball, the longer you hold... Oh, well, look at that. It's boiling up. Look how fast it's going. Oh, mama. Pardon me, ignore that. Just look at it go. Oh, look at it. Man, this is what kinetics are like. Now you understand? This is kinetics in progress. Just ignore. I know. Usually this is around the time when I eat dinner. So I know there's a rubric. I'm well aware of a rubric in this place. So I had to do my best. What? What? It's my first time recording it. What do I look like? What do I look like? Some newborn kangaroo? Hmm. Let's see. Let me. Look at all the bubbles. They keep popping. Oh, you noticed about the hole in this lid? I had to get them out somehow. Otherwise, the lid inside the lid inside it. Otherwise, the liquid would crack. Yes, that's right. If you contain some form of energy inside one place for a single time, it'll store up so much energy, it'll cause whatever object inside it will burst open. And this is a warning. In kinetics, you shouldn't store up so much energy in one place. Hold on. I know this is not really. This is not related to kinetics, but if you store up too much energy in one place, it has to go out somehow. Otherwise, you'll burst. Otherwise, you'll explode. Just like a water balloon with too much water. You get the idea. Either way, time for me to shut this down. What? Can't risk having a fire hazard, now can I? Now, back to my potential energy experiment. Let's see how my little pebble, or in this case, your imaginary boulder, will form. With all that energy poured up, let's see if it will break. First, let me put down the target. Let's see if it lands. Oh, it didn't break. How sad. And as this is in the floor, so in the trash it goes. Well, yeah, I was hoping it would shatter into tiny pieces, because potential energy is all about stockpiling. The longer something is stocked up inside, the faster it will fall from a cliff. So that's why I used the sugar as a boulder, an example of an imaginary boulder. You don't know why most boulders are made of stone? Oh, hold on. Sorry, a little off track. Do you know why most boulders shatter into pebbles upon impact? Well, that's because they store up a lot of potential energy, and the resulting kinetic energy will cause it to slam down to the crater and shatter into pebbles, just like what happened with my kinetic experiments over there. You saw all the tiny. I'll do that with some drawings. Be right back. Demonstration. Low potential energy. And kinetic energy. Also, this might be a bit complicated for you to understand. That includes the rate laws as well. more complicated. I know. It's very difficult when I understand. Something. Oh, I'm a bad artist. Okay, I'm back. Allow me to show you my illustrations. Keep in mind it's been hand drawn, so. Hold on, let me get into a better lighting. There. You see, this is what happens when potential energy is applied in here. Now again, the longer something that stores up power, the more force it will generate upon release. See that? That was the sugar cube I used. And this would have been happened if I wasn't inside my own apartment because of COVID. Now, this is more complicated. This is my kinetics side of the experiment. You see, water usually boils after 5 minutes. Well, in this case, you can prove me wrong. But either way, look at this illustration. This is my pot from before. See all those little circle, those molecules? They're still close. And this is what happens after they becoming gas. You see, kinetic energy is all about the motion. The longer you move, and the more energy you exert, and the more heat you produce. This is exactly what happened when I was making boiled eggs. It was exerting so much heat that I could feel in my hand. Well, as for the science of my experiment is to demonstrate how kinetic energy is surrounding all over around us. There are different ways kinetic energy can be manipulated. Also, there was potential energy. You can actually see it happening on real life. Remember that boulder and forest example? Sometimes you have a kind hike around the mountains. All of a sudden, you hear a loud boom. Next thing you know, it was a huge boulder smashed into tiny pebbles. This is my kinetics video. Goodbye.